The purpose of this video is to provide an interpretation on the mathematical symbols involved in the Biot-Savart law. Equations like the Biot-Savart law may be introduced in physics courses without students understanding the mathematical notation. I'll attempt to explain the symbols in the equation at a high school or Calculus 1 level. This video will not go over the physical derivation of the law. In electromagnetism, the Biot-Savart law expresses the magnetic field at any point in space, given a thin wire carrying electric current. This is what it looks like. Mu naught is the vacuum magnetic permeability, while I is the electric current. The Biot-Savart law involves a special integral that works on curves. Unlike definite integrals encountered in introductory calculus courses, this integral works along a curve, called C, which is defined by the function L. L returns a position, or vector, on C, and the integral is simply traversing through this function between the bounds of C. We're essentially riding along the curve and accumulating small values. Every integral requires a differential. The symbol dl is the differential form of L. This tells us the infinitesimal change of L at a point on this curve. You can see it shown as a small green arrow. R is the position of interest for which we wish to evaluate the magnetic field. This is usually a vector. On the right is the close-up of this curve. Notice how we're traversing along infinitesimal steps. Let's focus on the inside of this integral. This purple expression is the cross product of dl and the difference between r and l. The cross product is a vector operation. The result is still a very small vector. It points perpendicularly to dl and r minus l. Finally, we divide by the cubed length of r minus l. Some textbooks might write it differently. They might define the function b as a vector field representing the magnetic field, and then they might introduce the symbol dB. dB is not the differential form of b, rather it's shorthand for this large expression. Intuitively, this is the infinitesimal magnetic contribution onto r due to a point L on the wire. Integrating this throughout the bounds of C, we get our familiar Biot-Savart law.